To big data and Hadoop. As we have been discussing what is data and what is big data, and we would also see what Hadoop is all about. So in continuation of the discussions that we already had, now let us understand, before we understand what Hadoop is, let us understand what is data and how you can define data, and what is the difference that we have between data and big data. So data and big data, so we'll see the difference between data and big data, and also we'll see what are the different sources that we have, that are actually contribute to so much of data that is available in the universe out there. So before we understand what Hadoop is, let us understand what data is or what big data is, and we'll understand the role of data in the universe. This is very important. As we have been saying, everything is data driven, so we need to understand the role of the data in the universe. Next question is, what is the advantage of big data for an organization? Okay, we'll all see all these questions, and also we'll answer all these questions one after the other. Now, what is data? Data which is not processed, or data which is not processed can be called as anything which is raw can be called as data. So generally the digital streams that individuals are producing are growing at a faster rate. Now each and everybody is producing a lot of data, it's contributing to a lot of data, in fact I would say a lot of big data. Now there was a project done by Microsoft called as My Life Bits, and actually this is one of the projects which they try to archive personal information of each individual, and that would be actually combined and kept in this project so that would be useful for the future use. So this data may comprises of phone calls, emails, documents, and they all capture and they try to keep it in one place. See, when you look at this My Life Bits project, this is a combination of phone calls, that is audio files, emails, that is could be a text file, or any other documents. So here Microsoft has tried to capture different forms of data. The point here we have to understand is they did not capture only one form of data, they captured all the different forms of data. Now the data gathered included a photo taken every minute, which resulted in an overall data volume of 1 gigabyte a month. So if they started, if you have, for example, if they started to capture each and everything of an individual, actually is contributing a gigabyte, 1 gigabyte of data a month. So the trend is for individuals, data outprint is to grow very fast. So in fact, the amount of data generated by machines will be ever greater than that generated by people. That exactly true. So whatever the data that is generated by the human beings is very less than that of generated by all the machines. For example, machine logs, RFID readers, vehicle GPS traces, all of these contribute to growing mountains of data. So we live in the data age. So it's not easy to measure, because we have seen, so if you look at the statistics of how the data actually is growing, it's very astonishing. See IDC, there is an already we have mentioned about this IDC, International Data Corporation. In 2006 they did a research on what is the digital data available in the universe, what is the data that is available, digital data available in the universe. So 2006 they did a research, International Data Corporation, and they found out the whole digital data, the entire digital data in the universe, that to be 0.18 zettabytes, and by 2011 it has grown to 1.8. Now you look at from 0.18 to 1.8 zettabyte, it's almost tenfold growth in the data. So much of data is being produced. So we all know that there are so many sources. If I ask you to name few, you can name any, because everybody is dealing with the data now. In 2012 it reached to 2.8, and also what IDC has forecasted is by the year 2020 it's going to be 40 zettabytes. It's humongous, it's very huge data available in the universe. So we will understand what is a zettabyte actually. So now if you look at this information, then look at this, probably you'll understand what a zettabyte is. A zettabyte is nothing but 1024 exabytes is equal to 1 zettabyte. So you can actually go through the how the memory would be measured. So probably this is very important for a big data or Hadoop developer to have knowledge on all these calculations. Now we are saying that data is exploding, data is growing. The flood of data is coming from many sources. For example, stock exchanges and the very famous Facebook or ancestry.com. It's a genealogy site. It says it stores around 2.5 petabytes of data. The terabytes is almost gone now. Everybody is dealing now petabytes of data, so terabytes to petabytes. So now here Internet Archive stores around 2 petabytes of data and is growing at a rate of 20 terabytes per month. So this is how the data is being exploded. So we are driven by data. Now not only the machines that are generating the data, now let us come what a human being can do, or contribution of a human being, the people. The people upload videos, take pictures on their mobile phones, they text to their friends, they do update on their Facebook, leave comments. So everything is generation of the data. So machines too are generating and keeping more and more data. So the exponential growth of data first presented challenges to cutting edge business such as Google, Yahoo, Amazon and Microsoft. Now let us talk about what Google actually would do, what Yahoo also would do, what Amazon would do and what Microsoft would do. If you look at all these companies are dealing with data, very humongous data. Let us suppose the most common Google. Now Google, whatever you want, wherever you want, you just type in anything, whether it is good or bad, related to any form of information, anything that you wanted to know, you type in Google, you will get the information. That means Google itself hosts so much of data. Google has so much of information for its users, so it's a huge platform to hold so much of data. Same with Yahoo account, so much of information they also would store in their databases. So now so much of data is available. Now we have been saying that yes, data is there, so much of data is being exploding, but how do I handle this always is a question. How do I handle that is always a question. So there is an answer. So always we have to remember this statement: there is a problem and there is a solution. The problem is big data. That means so much of data available out there in the universe. So that's a problem. How to store it and how to do something with the data are the problems. Now there is a solution again. The solution is, the answer is Hadoop. The answer is Hadoop. So remember, the problem is big data, the solution is Hadoop. So now let us see how can we handle, or what do we do with this big data available. And also remember, as we have been saying, big data is a combination of 3 V's or 4 V's. So 3 V's, so volume, variety and velocity. And okay, now these are the different sources that each on everyday basis how the data being uploaded. If you take YouTube, users upload 48 hours of videos every day, of new videos every day. If you look at Google, receives over 20 lakh search queries. Facebook users share some 6,84,000 shares. So humongous data, it's very astonishing and very kind of when we look at this, everyone will be surprised at how much data is being generated on a daily basis. So I wanted to look at and also understand what is the different sources generating how much of data. So we come across data in every possible form. The meaning of the statement is you have videos, you have audios, you have pictures, you have text messages and whatnot. Everything is a combination of big data. So this is when we call it as a big data. So there is kind of voluminous, and there is a variety, and there is velocity. Now that's when we call it as a big data. So as we have been mentioning, big data can also be defined as any data which is beyond the processing capacity of existing infrastructure can be called as big data. So my infrastructure, my existing infrastructure cannot actually handle my big data, what is being so I need a different platform, or I need a different thing where I can actually store the big data. So we have some other definitions also for big data. So according to IBM, what they say is any data which has got 4 V's can be called as big data. Now let us see what are those 4 V's. So the first one is volume. Big data is clearly determined by its volume, and yes, so if you look at the statistics, very huge voluminous data. Next is the velocity. Velocity means the rate at which data is flowing in the companies. So now here lot of data is being flowing. For example, processing 2 million of record at share market, or evaluating results of millions of students apply for competitive exams could mean actually big data. So you have to do so many things about if you look at the volume, that's very high. Next is the variety. Now big data may not belong to a specific format. This is very important. So this is very important. This is what big data is all about. So yes, voluminous is yes, there is velocity, and the next characteristic that big data has is variety. Now when you look at variety, so data can be as we have already mentioned, data can be categorized, or it can be divided, or data, you find data in 3 forms. One is structured form, semi-structured, unstructured, or we can divide the data as structured data, semi-structured data, unstructured data. So structured, semi-structured, unstructured examples are text, images, audio, video files, log files, emails, and 3D models, etc. Now let us see veracity. So veracity refers to the uncertainty of data available. Data available can sometimes get messy and may be difficult to trust. With many forms of big data, quality and accuracy are difficult to control, like the Twitter posts with hashtags, abbreviations, typos, and colloquial speech. Now this is something everybody do on the Facebook for different things. We have our own abbreviation set up to mention certain things. So I would like to again read this. With many forms of big data, quality and accuracy are difficult to control. Example, like Twitter posts with hashtags, abbreviations, typos, and colloquial space. But big data and analytics technology now permits to work with these types of data. The volumes often make up for the lack of quality or accuracy. So no matter how much data, or no matter what form of data, no matter how if it is inaccurate or accurate, every form of data can be dealt with big data. So big data is a combination of complex data that becomes very tedious to capture, store, process, retrieve, and analyze. Yes, the problem is how to capture. The problem is how to store, and the problem is how to process and retrieve and analyze it. So the concept of big data may vary from company to company, because some companies may deal with terabytes of data, some companies may deal with petabytes of data. So the problem of big data is different for different companies. So here I'd like to make a statement here. The good news is that big data is here. The bad news is that we are struggling to store and analyze it. So this is you have to remember, the good news is, yes, we have so much of data available. The problem is how to store it, how to analyze it, and how to process the data. Now let us see, there are certain advantages of processing. Now, as we have been asking ourselves, what is the advantages for a mid-sized company with this big data? Now, data had never been as crucial as before as it is today. In fact, we can see a transition from old saying, customer is king, to data is king. Yes. So in fact, we can see a transition from there is an old saying where we always used to say customer is king to customer is king. Now it has changed to data is king. So customer is king to data is king. For an efficient decision making, it is very important to analyze the right amount of data and the right type of data. So what is the advantage of big data? What is that I can get out of this data to the company? So what you can get is an efficient decision making. If you analyze the right amount of data and the right amount of data, then you can take some efficient decisions out of your analysis. So healthcare, banking, public sector, pharmaceuticals, IT, all need to look beyond the concrete data stored in their databases and study the intangible data in the form of sensors, images, and weblogs. In fact, what sets smart organization apart from others is that ability to take the advantage of the data efficiently, to allocate resources properly. So it's not that you have so much of data, but you need to analyze the right amount of data. And what happens when you do that, it actually sets your organization apart from the other organizations. So it's not that you have so much of data, you also need to store it, capture it, and analyze it. Now, big data can unveil some really useful and crucial information which can change decision making process entirely to a more fruitful one. So big data makes customer segmentation easier, more visible, enabling the companies to focus on more profitable and loyal customers. Now this point we have to be a little careful, or I would like to re-emphasize again, big data makes customer segmentation easier and more visible. Yes. So when you have so much of data, so you captured the data and you stored the data, so you have analyzed the right amount of data. Now what happens, let's say I am working on, I have a big company where I wanted to know what's customers thinking about my company, or what is that the customers are actually feel about the service that we provide. So this analysis of big data would really help you to how you can segment, segmentation, or how you can actually divide. So big data makes customer segmentation easier and more visible, which actually helps the company to focus more on profitable and loyal customers. So without which doing an analysis, you cannot reach to a conclusion saying that okay, he is a loyal customer or he is not, or he is the one actually invests so much of money, or he buys so many things from the company. So big data, so this is all what are the advantages. So we get that these are the advantages. So these are the advantages that we have when we are dealing with big data. So the way in which big data is explored and used can directly impact the growth and development of the organization. That's very true. Now, yes, we have so much of data, right? So we have to store it somewhere. See here guys, we did not have come to the concept, or what is that Hadoop can do for the big data. We till to that point we did not come yet. All we are trying to understand is what is that data is doing in the universe, or what are the different sources of the data, and what forms of data are being produced, and what is the use of this big data for a common man. So now let us talk about the data storage and analysis. Now let us talk about data storage and analysis. Now here while the data storage capacity of hard drives have increased massively. Now yes, so 10 years ago from now the maximum I believe is the 500 GB, or even when I first bought my first desktop, my whole hard disk capacity was 1 GB. So now if you look at if today's scene, or today's the configuration of the systems, even 4 GB is your RAM. So there is a drastic improvement or a change, or there is a change in the storage capacity of hard drives. Now the norm is 1 TB. So here if you see, the storage capacity of hard drives have increased massively. Means so over the years, access speeds, the rate at which data can be read from drives have not kept up. Here this is very important point. I have my hard disk capacity being increased. Over the years, yes, the capacity of the hard disk, the becoming big and big, from 500 to 1 TB, 1 T to 1 PB. But the problem is here the data, the rate at which the data can be read from drives have not kept up. So it was not in par with with the hard disks, the way it's been growing. So one typical drive, now let us say for example, one typical drive from 1990 could store 1370 of MB of data, and had a transfer rate of 4.4 MB. So you could read all the data from a full drive in around 5 minutes. So this is an example in 1990. So let us say there is a hard disk which can actually hold 1370 MB of data, and at a transfer rate of 4.4 MB of data. See here, if you calculate this processing speed, okay, so for each second it can process 4.4 MB of data, and the hard disk capacity, this is in the year 1990, that is 1370 MB. So if you have the transfer speed at 4.4 MB per second, so the whole full drive can be read in 5 minutes. But over the 20 years, let us say 2016, 1 terabyte is a norm. Let us talk about data storage and analysis. Now let us see some examples. We have seen how to store the data. There are yes. Now let us understand more about data storage and analysis. Now, well, the storage capacity of hard drives have increased massively. Yes. So from 10 years from now, if you look at the capacity of a hard disk, that used to be 250 GB, 500 GB. In fact, when I first bought my desktop, my hard disk capacity was 1 GB. But nowadays, even 8 GB is the capacity of the RAM. Now here over the years, now if you look at the storage capacities, there is a drastic change in storage capacities. But whereas over the years, access speeds, the rate at which data can be read from drives have not kept up. One typical drive, for example, you have a drive, let us take a drive, hard disk in 1990, which can store 1400 GB of data and had a transfer rate of 4.4 MB per second. So the time taken to read the entire data at the rate of 4.4 MB per second, it's only 5 minutes. But over 20 years later, so now let us say 1990, this was the trend, but after 20 years, 1 terabyte of hard disk is the norm. but the transfer speed is around 100 MB per second. So still there is a increase in the transfer rate, but it takes more than 2.5 hours to read all the data of the disk. See, if you remember, if you look at 1990, I had a hard disk which I can hold 1300 MB of data, and I can transfer the data at a speed of 4.4 MB per second. So now the total time taken to read the entire data from the entire disk is 5 minutes. After 20 years, when hard disk capacity has become 1 terabyte as a norm, and this processing speed is again 100 MB per second, but it would take 2.5 hours to read all the data of the disk. So there is always a bottleneck when it comes to processing the data. So if you look at how the data hard disk capacities are increasing and how the processor speeds are increasing, there is a huge gap in between. So 20 years from now, 1990, if I have a capacity of 50 GB, or that's a big system that I have, but nowadays 1 TB has become a norm. But if you look at the processing or the time taken to read the data from that disk is not kept up as good as the hard disk capacities. Now, so again, let us say different source of data, structured, semi-structured and unstructured. This is very important. Now, application data which has got high volume and structured, high throughput, machine data, high velocity, semi-structured, machine data, semi-structured, ingestion at a high speed, social data, it's all social networking data, YouTube, Facebook, and whatever Twitter you have. So there is a lot of variety in the data, and highly unstructured, and there is a veracity as well. Now there is something called enterprise data. Again, there is a variety, highly unstructured and high volume. So big data technology enables IT to leverage multiple sources of data. So you have multiple sources of data. You have application data, which is actually comes under the structured form of data. You have machine data, which can come under semi-structured data, and you have social and enterprise data. We can keep them as unstructured data. But again, we'll see what is the definition of structured, semi-structured and unstructured. But here, if you look at the diagram, we'll come to a conclusion of what is an application data, or what is the structured data, what is semi-structured data, and what is unstructured data. So here it takes long time to read all data from one single drive, and writing is even slower. Here to read data from any single drive, time taken is so long. The obvious way to reduce the time is to read from multiple disks at a time. Yes, see here, I cannot have all the data stored. Now here, now from this point onwards, we are actually moving towards why we wanted to have Hadoop in order to have big data stored. So the point here is, yes, we have so much of data, and we have very big hard disk capacity as well. And if you as in we have seen that there is a humongous growth in the capacity of the hard disk. Now the 1 TB has become the norm. Now here, in order to have everything on single hard drive, or everything on single hard drive, obviously it takes a lot of time to read the entire data. So that's where what we are saying is the obvious way to reduce the time to read data from multiple disks at once. Imagine if we have 100 drives, each holding 100 of data, working in parallel, we could read the data in under 2 minutes. Now let us again do this. This is a long time to read all data on a single drive, and writing is even slower. The obvious way to reduce the time is to read from multiple disks at a time. Here what we are saying is, in order to reduce the time of reading the data from the disk is to keep the data on multiple disks at once. Here we are not talking about one disk, we are talking about multiple disks. Remember, multiple disks. So for example, you have 100 drives and each drive holding 100th of the data. So if you work, now let us say you have 100 hard disks. On 100 hard disks you have kept a little data on all, or you have kind of distributed the data on this 100 hard disks. So if you wanted to read the data, or data from all the different 100 drives, so working in parallel, we could read the data in under 2 minutes. So this is very important. Now one disk to many disks, reading from one hard disk, reading parallelly. So again, parallelly. I hope you all understand what is a parallel processing. Parallel processing is something which you can make any task working simultaneously. It is not that you do this, then again I'll do this. No, we all work together at the same time, so result can be combined. So what happens is, parallelly if you work, your processing speed, or you can do that work so quickly. So there is more being able to read and write data in parallel to or from multiple disks. So what happens, there are certain things, there are certain problems when you have this data, if you wanted to read the data parallelly. So this is very important. See, what we are saying is, to increase the processing speed, data can be read parallelly. Yes, that's one point. Now we'll see what is a parallel, how do we read parallel, and what is the relation between this parallel and the Hadoop or big data and its subcomponents. Now if you wanted to read the data, if you wanted to increase the processing speed, yes, you can read the data parallelly, but there are certain problems. The first problem is to solve is hardware failure. Let us say I have distributed the data, I am trying to read or 100 hard drives I have a little of 100 the data on each of these hard disks, and if one hard drive goes down or hardware failure, as soon as you start using many pieces of hardware, the chances one will fail is fairly high. Yes, so if you have distributed your data parallelly, but there is a huge chance of hardware failure and data loss. So how to avoid that is the question. How do I avoid it? Common way of avoiding data loss is through replication. Common way of avoiding the data loss is through replication. So redundant copies of data are kept by the system so that in the event of failure, there is another copy available. So three terms here in this slide we have to understand: data being read parallelly, next is hardware failure, answer is have a replication of the same data in another disk. So parallelly, replication. Now please do concentrate on two terminologies: parallel, data loss, and replication. So this is how RAID works. RAID is the full form of RAID is redundant array of inexpensive disks. So this is an old concept actually, where you have read the data parallelly, and where you have to avoid data loss, have the factor of replication. Or now that's the first problem. The second problem is that most analysis tasks need to be able to combine the data in some way. Data read from one disk may need to be combined with the data from any other 99 disks. Now here the second problem is, how do I combine the data? Yes, I have trying to read the data parallelly. Now my question is, how do I actually combine this data? So various distributed systems allow data to be combined from multiple sources, but doing this correctly is very, very challenging. Yes, so there are certain distributed systems which actually allow data to be combined from multiple sources, but the challenge is, how do I do that? How do I do that correctly? So again you have an answer for this. Again you have an answer for this. The answer is MapReduce provides a programming model that abstracts the problem from disk reads and writes. So MapReduce. Now we have come across a new terminology called MapReduce. So here again, see, we'll try to again understand one more time. So hard disk capacities have increased massively, but over the years still the processing capacities have not increased that good. So in order to have my processing faster, what I will do is I'll keep the data on different hard disks. Now what I'll do is I can read it parallelly so that my processing speed would increase. That well and good. Next is while doing this, I may have different issues or different problems. One is the data loss. So again the answer is, if I wanted to avoid the data loss, I need to have something called as replication. I need to have the same amount or the piece of data available on other systems. The second problem is, how do I combine the data, because it's a very tough task to combine the data from different hard drives. Again the answer has come as MapReduce. So where do I have MapReduce? MapReduce again I do have in Hadoop. So in a way of saying, so data storage and analysis. Data storage is possible in Hadoop, analysis also is possible in Hadoop. In fact, Hadoop can be defined as Hadoop is equal to HDFS, Hadoop distributed file system, plus MapReduce. We would be looking at in depth of what is HDFS and what is MapReduce. So Hadoop is equal to HDFS plus MapReduce. So imagine you have 1 GB of data that you need to process. Now yes, the data stored in relational databases, no problem handling this much of data. The problem arises when data grows from GBs to TBs. See here, why is really data growing? Yes, it is growing. We have seen all the examples and we have seen so much of information pertaining to the different sources of data that are available. Now yes, I am doing good because I have limited amount of data, but the problem comes is what happens when my data actually grows. So my data started growing from 1 GB to 10 GB and again from 10 GB to 100 GB. So it has become again 100 GB to 1 TB. So we need to derive information from both the traditional data and the unstructured data and wants this information as soon as possible. So if you look at the kind of exponentially increasing of the data because of the different sources that we have, so we need to have a solution, because my traditional RDBMS it's becoming tough for my RDBMS to handle the data.